A single tube of blood. That's all it takes. No scopes, no biopsies, no radiation. Just one vial drawn from your arm, and a machine learning algorithm scans it for molecular signatures from over 50 different cancers before you feel a single symptom. And what's fascinating is this isn't science fiction anymore. Right now, in early 2026, we're weeks away from learning whether this actually works at scale. The NHS has been tracking 140,000 people for 3 years, and the results are about to drop.
This could be the moment we've been waiting for in cancer medicine, or it could expose one of the most overhyped technologies in recent memory. Either way, what happens next will reshape how we think about early detection forever. It's time to understand this deeply.
Let me give you the number that explains why the UK bet £150 million on this experiment. Every year, cancer kills over 167,000 people in Britain. But here's the critical detail. 70% of those deaths come from cancers we don't routinely screen for. Think about that. We have mammograms for breast cancer, colonoscopies for bowel cancer, but pancreatic cancer, ovarian cancer, esophageal cancer? By the time you notice something's wrong, you're often already at stage 3 or 4.
And stage matters enormously here. The clinical trial data shows that late-stage diagnoses account for roughly 2/3 of cancer deaths from unscreened types. The survival curves are brutal. Pancreatic cancer caught late has about a 10% 5-year survival rate. But what does this mean for patients who catch it early? Those odds can flip dramatically. That's the fundamental promise driving this entire endeavor.
The test is called Galleri, developed by a company called Grail, and the technology works by detecting something called cell-free DNA. When tumors grow, they shed tiny fragments of their genetic material into your bloodstream. These fragments carry methylation patterns, essentially chemical tags that differ between healthy tissue and cancer. Grail trained machine learning algorithms on thousands of blood samples to recognize these patterns, not just to detect cancer, but to predict where in the body it originated. Pancreas, ovary, liver, lung.
The NHS trial, which wrapped up recruitment back in 2022, randomized participants aged 50 to 77 into 2 groups. Half received annual Galleri blood draws for 3 years. The other half got standard care. The primary question, does this shift diagnoses from late-stage disasters to early catches?
And the recruitment itself was remarkable. They used pop-up clinics in supermarket car parks across England, mobile units that made participation accessible. They invited 1.5 million people and enrolled 140,000 in months, 5 times faster than typical clinical trials.
What gives me hope about this research is the equity angle. Rural communities, ethnic minorities, groups often underrepresented in clinical trials showed strong participation. This wasn't just a London experiment.
The key players here are worth understanding. Grail owns the intellectual property, the patents on methylation-based multi-cancer detection. The NHS provides the data infrastructure through cancer registries. Cancer Research UK handled recruitment logistics.
And, behind Grail, the company spun out of Illumina, the genomics giant, with backing from Jeff Bezos, among others. We're talking about serious capital betting on this technology going global.
Now, let's break down what the science actually shows. Before this massive NHS trial, Grail ran smaller studies. The most important one, called Pathfinder 2, enrolled about 23,000 people and published results at major oncology conferences. The headline numbers, 40.4% overall sensitivity. That means the test detected about 4 in 10 cancers present in the blood samples. Specificity hit 99.6%, meaning only 0.4% of healthy people got false alarms.
I need to pause on sensitivity for a moment, because this is where the educational rubber meets the road. 40% sounds low, right? Miss 6 out of 10 cancers? But here's the context that changes the picture. For the 12 highest mortality cancers that Gallery specifically targets, pancreatic, ovarian, esophageal, and others, sensitivity jumped to 7%.
That's actually surprising to me because it reveals something crucial about how this technology was designed. Grail didn't try to catch every cancer equally. They optimized for the killers, the ones without existing screening programs, the ones where early detection matters most.
The mechanism works like this. Imagine your bloodstream as a river flowing past every organ in your body. When a tumor develops, it's like graffiti appearing on the riverbank. The tumor sheds DNA fragments with distinctive methylation signatures, chemical marks that healthy cells don't produce. Gallery's algorithm is trained to spot that graffiti and trace it back to its source. It's not looking inside your organs. It's reading the messages your organs send into your blood.
From an evidence-based perspective, the positive predictive value matters enormously here. In Pathfinder 2, when Gallery flagged a potential cancer, about 61.6% of those signals were confirmed after follow-up testing. That's up from 43% in earlier versions. Translation: 6 in 10 positive results lead to actual cancer diagnoses. The other 4 require additional scans or biopsies that ultimately find nothing.
But wait, there's a critical limitation we need to address. Early stage sensitivity, stages 1 and 2, hit only 27.5% in Pathfinder 2. The test is better at finding cancers that have grown enough to shed detectable DNA.
That's making me reconsider the framing here. This isn't a replacement for existing screening, it's a complement. The real-world implications are that you'd still want mammograms and colonoscopies. But Gallery catches cancers those tests miss entirely.
Studies combining Gallery with standard mammography showed 3 times more cancer detections than mammography alone. That's the additive value.
The NHS trial's primary endpoint isn't mortality, at least not yet. They're measuring absolute reduction in stage 3 and 4 diagnoses for those 12 high-burden cancers. Models published in JAMA predicted a 6 to 23% reduction over 3 years.
If that holds, the downstream mortality benefit could reach 6 to 9%, but proving that requires longer follow-up than the trial was designed to capture. Let me tell you about 2 hypothetical participants that represent the extremes of what this trial might reveal. First, there's someone we'll call Jane. She's 62, feels perfectly healthy, no family history of cancer that would flag her for extra screening. Jane gets her annual Gallery blood draw. 2 weeks later, a call from her GP. The test detected a signal consistent with ovarian cancer. Urgent CT scan ordered. They find a stage 1 tumor. Surgery removes it completely. 5 years later, she's cancer-free.
That's the dream scenario. Ovarian cancer is notoriously difficult to catch early. Symptoms are vague, bloating, fatigue, things women often dismiss. By the time most cases are diagnosed, they've already spread. The patient experience tells us that early detection fundamentally changes the conversation. Instead of aggressive chemotherapy with uncertain outcomes, Jane gets curative surgery.
But now, consider Tom's same age, same trial. His Gallery result comes back flagging a liver signal. He's terrified. The follow-up CT shows nothing definitive. They order an MRI. Still unclear, then a biopsy. Weeks of anxiety, invasive procedures, radiation exposure from multiple scans. Finally, the verdict: no cancer found, false positive.
The trial specifically tracks this psychological impact using something called the STAY-I-6, a standardized anxiety assessment. Scores above 49 indicate clinically significant distress. In Pathfinder 2, about 24 to 38% of positive results were initially false alarms before the refined algorithm improved. That's a lot of Toms experiencing what researchers call the worried well phenomenon.
From a patient outcome perspective, this is the core tension. Every cancer caught early represents potential lives saved. Every false positive represents unnecessary anxiety, procedures, and healthcare costs. The NHS is tracking all of it: additional imaging ordered, invasive procedures performed, radiation exposure accumulated, quality of life measures.
Quantitatively? If Pathfinder 2's detection patterns hold, about 53.5% of cancers found would be stage 1 or 2. For a healthcare system spending billions annually on late-stage cancer treatment, that shift represents enormous potential savings.
But the human story isn't just about individual patients. Consider the families. The spouse who spends weeks not knowing if their partner has cancer. The children watching a parent undergo test after test. The psychological toll ripples outward.
And then there's the equity dimension. Mobile clinics in supermarket car parks reach communities that typically don't engage with preventive health care. Rural England, working-class neighborhoods, populations with historically worse cancer outcomes.
If Galleri works and becomes accessible, it could help close gaps that have persisted for decades. But that "if" is doing a lot of heavy lifting right now.
Let me push back on the optimism for a moment, because there are serious unresolved questions that the mid-2026 results may not fully address. First, sensitivity. 40% overall means missing 60% of cancers. Critics, including some prominent voices in the British Medical Journal, have called the early-stage detection rate strikingly low.
That's a fair criticism. If you're selling a test as early detection, detecting only 27% of stage 1 and 2 cancers is problematic. The test works better for more advanced cancers, which somewhat undercuts the core value proposition.
Second, overdiagnosis risk. Not all cancers are created equal. Some grow so slowly they'd never cause symptoms during a person's lifetime. Prostate cancer is the classic example. Many men die with prostate cancer, not from it. Finding these indolent cancers through blood screening could trigger aggressive treatment for conditions that never needed treatment. That's harm masquerading as benefit.
The patient experience tells us this is real. People who receive cancer diagnoses, even for slow-growing tumors, often want action: surgery, radiation, chemotherapy. The psychological burden of knowing you have cancer, even a harmless one, changes how you live.
Third, and this is where it gets complicated, publication bias. The NHS trial hasn't released interim results publicly, but leaked documents and reports suggest the data wasn't compelling enough for immediate rollout.
That phrase, "not compelling enough," is doing a lot of work. What does it mean? Sensitivity lower than expected? Stage shift smaller than modeled? We don't know, because the data remains unpublished.
From an evidence-based perspective, company-funded trials that don't publish disappointing interim results raise red flags. It's a pattern we've seen before in pharmaceutical research.
And then there's the regulatory and commercial context. Grail has been lobbying aggressively, reports link the company to meetings with former Prime Minister David Cameron and former Health Secretary Nadeem Zahawi. The commercial stakes are enormous. Grail prices Galleri at $950 per test in the United States. They hold patents that effectively create a monopoly on methylation-based multi-cancer detection, no generics on the horizon.
The structural dynamics here matter. If the NHS endorses Galleri, Grail's market cap could soar. That creates incentives that don't always align with cautious, evidence-based medicine.
I'm not saying the science is wrong. I'm saying the institutional pressures surrounding this trial are intense, and we should understand them as we interpret whatever results emerge.
The fundamental question the trial may not answer: does stage shift actually translate to lives saved? It's possible to catch cancers earlier without improving mortality, a phenomenon called lead time bias. You diagnose people sooner, so they live longer with their diagnosis, but they don't actually live longer overall.
The trial wasn't powered to measure mortality directly. That would require years more follow-up, so even positive stage shift results will leave uncertainty about the ultimate benefit.
Let's map out what might happen when results drop mid-2026. Scenario 1. Strong, positive, stage 3 and 4, diagnoses drop by 15% or more for targeted cancers. The NHS National Screening Committee recommends a pilot program for 1 million people. In this scenario, Grail's stock price jumps. The FDA fast-tracks U.S. approval based on UK evidence. Other countries start their own trials. We're looking at a potential paradigm shift in cancer screening within 5 years.
Scenario 2. Modest, positive. Stage shift occurs but falls at the lower end of predictions, maybe 6 to 8% reduction. The committee recommends targeted rollout for high-risk populations only. People with family history, genetic predispositions, or occupational exposures. This is probably the most likely outcome based on what we know about the interim signals. Not a revolution, but a useful tool for specific contexts.
Scenario 3. No result. No statistically significant stage shift. The committee declines to recommend rollout. Grail pivots to marketing directly to consumers and private healthcare systems. The technology continues developing, but without NHS endorsement. This would be a significant setback, but not necessarily the end. The underlying science might still prove valuable with improved algorithms or different target populations.
Scenario 4, concerning safety signals. False positive rates higher than expected. Significant psychological harm documented. The committee not only declines rollout, but issues warnings about direct-to-consumer marketing. This scenario would set back the entire field of liquid biopsy cancer screening, not just Galleri.
And Scenario 5, which I think deserves attention. Mixed results that create controversy. Stage shift positive for some cancer types, but not others. Benefits concentrated in certain demographic groups. Data that different experts interpret differently. This is actually the most likely outcome for complex medical interventions. Reality rarely delivers clean narratives.
For listeners, here's what this means practically. If you're over 50 in the UK and results are positive, your GP might offer annual blood draws within the next 2 to 3 years. If you're in the US, expect Galleri to remain available through private pay at around $950, with potential insurance coverage debates ongoing. The prediction most experts agree on: multi-cancer early detection tests will become part of standard preventive care by 2030. The question is which test for whom and at what cost.
Connect this back to where we started. That one tube of blood? It represents a fundamental bet on whether pattern recognition in molecular data can outperform our current organ-by-organ approach to cancer screening.
The answer we get in 2026 won't be final. But it will shape how billions of dollars flow, how healthcare systems allocate resources, and ultimately, how many cancers get caught before they become killers.
Here's what I want you to remember from everything we've discussed. The promise of Galleri isn't that it catches every cancer, it's that it catches cancers we currently miss entirely. The 70% of cancer deaths from types without routine screening. Whether that promise becomes reality depends on data we'll see in the coming months. Watch for the stage shift numbers. If late-stage diagnoses drop meaningfully for pancreatic, ovarian, and esophageal cancers, we're witnessing something genuinely new.
And stay thoughtful about what the results mean and don't mean. Positive stage shift doesn't automatically equal lives saved. Commercial interests don't automatically equal bad science. The truth will be complicated, as it usually is with breakthrough medical technologies. This story isn't ending in 2026. It's beginning. And we'll be here to help you understand each development as it unfolds.
That's what Deeply is about. Taking complex stories like this one and giving you the context to actually understand them. Not just headlines, but mechanisms. Not just claims, but evidence.
We explore stories across science, technology, health, and society every day. New episodes drop regularly, so follow Deeply wherever you listen to make sure you don't miss what comes next.
Thanks for spending this time with us. Until next time.
Stay curious, stay informed, and we'll see you soon on Deeply.